Hi everyone, welcome again to my YouTube channel. My name is Fred. So today we're going to be looking at a little bit more complex link mechanism. Now if you are new to this topic, my advice is you go see a video I already did on simple link mechanism. With that, you will be able to understand what's going on here. Alright, so now straight up, here's a question that says, in the figure shown below, the mechanism consists of two cranks AO and BQ. Now this is crank AO and this is crank BQ, which revolves in opposite directions at the same speed. So these two cranks, this crank AO is pivoted at O while BQ is pivoted at Q. So AO revolves about O in a clockwise direction while BQ revolves about Q in an anti-clockwise direction. Okay, so at the same speed. So the cranks are joined by two rods PCB. So this is a rod PCB, okay, and AC, another rod AC. So AC is joined to BP or PB if you like at the point C. So these two rods are connected at this point. Now draw the locus of the point P. Now there's a point P here on this rod BCP, this point P here. You have to look for the locus or find the locus of the point P, the profile of the point P. Now here are the data given. BC is 120 mm, that is BC from B to C is 120 mm, that's 12 centimeters. AC is 100 mm, AC is 100 mm. AO is equal to BQ, so this is AO, the crank. Both cranks are equal, so AO is equal to BQ and is equal to 30 mm. Then OC is equal to 130 mm. This is OQ, not OC, OQ. That's the centers of both cranks. All right, 130. So from this point to this point is 130 mm. That's 13 centimeters. Then PC 40 mm, and this is PC 40 mm. So if BC is 120 mm, so 120 plus 40, that gives you 160. So from B to P is 160. All right. So what you do next is you use these data given to set up this. So I've already done that. I will just explain how I came about this. Okay, I've done part of it anyway. Now, so what you do is you draw a thin line. All right, you place your ruler, just draw a thin line, locate a point here and call it O. All right, now the distance between OQ is 130. So from here, this point center O, you measure 120 on this thin line you've drawn. All right, so this is 130. You needle at 130, so that gives you the center of the second crank. All right, so we were told that the crank is AO and BQ, they are 30, so you stretch 30 on your ruler. All right, so this is 30, sorry. All right, so this is 30 on my ruler. Okay, so with 30 you describe a circle about O. So you needle here, describe a circle. All right, then you needle here and describe a circle as well, thin line. So that's how I came about these two circles. Now what you do next is you divide the circle into 12 equal parts. I want to assume you already know how to divide the circle into 12 equal parts. If you don't know how to do that, go see previous examples on cycloid, epicycloid, and even link mechanism. So that's it. All right, so after dividing the circle, now you have to set up this link mechanism exact same way you're seeing it here. All right, so if you take a look at this AO, it's looking like 9 on the clock. Assuming there is a circle here, it looks like 9 on the clock. So this is it here. So you make this one a little bit thick, or rather thick outline, this line here. Then this one is look like 12 on the clock, so you draw this thick. So this is BQ and this is AO. I hope that's clear. So what you do next is to locate this crank, this shaft, the rod, the connecting rod, B, CP, and AC. So how do you do that? Remember, we are given BC to be 120 mm. All right, so stretch 120, that is 12 centimeters on your ruler. So here we have 12 centimeters. All right, then you keep this radius. Okay, just keep it and get another pair of compass. But if you don't have a pair of compass, you can also use a pair of divider. So for AC, what do we have? 100. So you stretch 100. So here, this is 100. That's 10 centimeters. All right, so you keep both fixed. So this is 120 and this is 100. Now let's go back to the drawing. Now remember, this crank here rotates clockwise while this one rotates anti-clockwise. So this is the starting position, so you call this 1. So if it is rotating clockwise, then this becomes 2, 3, 4, 5 up to 12. Okay, so there we have it. So this is moving clockwise 1, 2, 3, 4, 5, 6, 7 to 12, while this is moving anti-clockwise 1, 2, 3, 4, 5, 6, 7, 8 to 12. All right, so with this already stretched 120 and 100, so you needle on B1 at this point here. All right, now like I said, if you have a pair of compass, that should do the job. All right, so with this 100, that is AC. Now you also needle on 1. So this is 1 here. All right, then you needle on 1 here as well. So you discover that by the time you draw an arc here, okay, assuming this were to be a pair of compass and you draw another arc here, they will intersect at a point. But since I do not have a pair of compass, I'm only having a pair of divider. You can also use a pair of divider. So all you have to do is needle at the point of intersection, that's this point here. Okay, from 1. Remember, my pair of compass is at A1. All right, so there. And also remember, my pair of compass is at B1 here. Okay, so you draw an arc and you draw another arc, but this is a pair of divider, so you just needle on the arc. All right, so after doing that, you connect B through the point of intersection, this point of intersection. Connect, use a thin line for now, okay, and extend out because we still have to measure 40 from C to P. All right, then you connect A1 to the point of intersection with a thin line for now. So this is the point C. All right, so how do we locate P? So we were told that PC is what? 40 mm. So you measure 40 mm from this point. So this is 0 and this is 40. So this is the point P. So you can call it P1. You can call this point C1 because we have many C's and many P's. All right, so this is the initial setup. So you can see that it's looking like the setup given at the question now. So all you have to do is make this a thick line and make this one a thick line. But every other crank and shaft that will be coming in will be thin lines, okay, for clarity purpose. All right. Okay, so there we have our P1. Now with these two pair of compasses and a pair of dividers fixed at 120 and 100, okay, so you needle on, you needle at 2. Okay, so here also on this side, on the left side, you move to needle on 2 here. All right, I hope you got that. Now do not make the mistake of positioning your pair of divider or pair of compass on 12. No, this one is moving clockwise, remember, while this is moving anti-clockwise. So as you're moving this way, you're also moving anti-clockwise this way. So 2, 2. All right, so you locate the point where they will intersect. So always bring them together like this. Okay, so with this, if I draw an arc, I don't want to draw a long arc so it doesn't make the drawing look rough or crowded. So they will intersect at this point. So this is an arc, so they will intersect at this point. So I will just needle on the arc like this. So there's a point of intersection. So what will I do next? I will connect the line 2 through the point of intersection with a thin line. Now extend out and connect also 2 to the point of intersection. So if this is C1, this becomes what? C2. All right, then you now have to locate the point P. on this crank. Do not make the mistake of extending this out and locating P on it. No, you have to locate on BCP. Okay, so this is BCP, so this is B2, so you locate P2 because we have C2 here. All right, so you measure 40 from C2 again like you did for the first, and this is it, 40 here. All right, you can erase this excess and leave it there. So this is P2. Now you repeat the same thing. Needle on 3, your radius still fixed. Do not alter this radii, all right, of the pair of compass and the pair of divider. So you keep them fixed. This one is fixed at 120, this one is fixed at 100 according to the data given. So you move to 3, needle on 3 here, then you also needle on 3 on your left. Okay, look for the point of intersection somewhere around here. So always learn to bring them together so you don't cut a very long arcs and crowd the drawing with arcs. All right, so this is it here. So if you have a pair of compass, fine, but if you don't, use a pair of divider. A pair of divider. So this is the point of intersection. So you draw, you connect 3 through the point of intersection, extend, then you connect 3 as well here. Remember, these are thin lines now. Okay, they are thin lines. So you measure 40 from this point. This is 40. So this now becomes what? This is P1, P2. This becomes what? P3. So you continue. You do the same thing. Move to 4. You needle the 120 on 4. All right. Then you needle the 100 on 4 here. All right. So look for the point where they will both intersect. I think this is it here. All right. So there we have it. This is the point of intersection. Connect 4 through the point of intersection, and you connect 4 here through this point of intersection, and this becomes, sorry, this is supposed to be C3 and this becomes C4. So locate P. So you measure 40 because PC is 40. So there we have it, 40. So this becomes what? P4. So you repeat the same thing for 5, 6, 7, 8, 9, up to 12. All right. All right. So by the time you're done connecting all cranks and locating P, these are the points you should have. So we have P5, P6, P7, P8, P9, P10, P11, and P12. Okay. Now remember to always connect BCP and AC. Okay. So you use a French curve or a flexible curve, or you can even use a broomstick to connect the path traced. Now let me say this: when connecting the path, that is why it is very, very important for you to always indicate the number of P's, P1, because you might be tempted at this point to connect 3, for example 3 to 6 and to 5. Do you understand? So always follow the numbers in ascending order. So from P1, P2, 3, connect through 4, 5, through 6, 7, 8, 9, through 10 to 12. All right. Okay, so there you have it. Now you can use a flexible broomstick, all right, to achieve this, or you can as well use a French curve. Now, if you do not know how to connect curves like this, there is a video I did on how to connect the curves of an ellipse. Okay, the locus of an ellipse. Okay, so you can go check it out. I did a video on that actually. So very, very simple, as you can see. So if you find this video helpful, just hit the like button, and do not forget to subscribe to my YouTube channel, and also recommend to anyone whom you feel actually need this. Thanks for watching. Have a nice day.